Now think about the switch, right? So we have a switch. I'm going to make it a little bigger switch now. Eight ports, okay? And out of the box, switch is a real simple thing. It doesn't even have a on and off button. All you have to do is like plug it in and start working, right? It's pretty simple. And out of the box, they have, as Terry mentioned earlier, there is a VLAN. There's a default VLAN, VLAN 1. And every port belongs to it as a default. Okay, it's a virtual LAN, so it's a segment. It's a broadcast domain. Okay? And let's say that you have A and B. A and B attached to it. Okay? Out of the box, would A and B be able to talk to each other? Without any modifications. Plug it in. Would it talk to each other? Would it? It's a yes or no. Dave. That's right. Yep. You'll be right, Dave. Yep. Raymond. Exactly. Because they're on the VLAN. Okay. It's like connecting to a one bus. Okay? Then somebody goes in and changes the VLAN configuration. Okay. So now the VLAN then is, let's say I have two VLANs now. Okay. So we have VLAN 2 and VLAN 1. Okay. And all the ports, here are the ports that are assigned to it. Here are the ports that are assigned to it. Okay. Now, would A and B be able to talk to each other now? Yes or no? Okay. That's right. You'd be correct. Because now it's on two separate segments. Albeit it is virtual. Okay, it's not like you're cutting the physical cable into two and have an air gap between, right? But it's as if you're doing that. So no, you cannot. Okay. So the question then is, why would you even do that? Why would you even want to separate these two folks out? What would be the reason why you would segment them into two VLANs? Too much broadcast traffic? Sure, right? So now you separate these things out into two broadcast domains. That's very good. So it would be for performance reasons. What's another one? Isolate the network for what reason? Different levels of security. That's right. So we talked about yesterday the concept of security domain. So if A and B are in two separate security domains, that is, they have the different expectations for security requirements, then you will separate those things out. Yeah, Dave. Dave, were you going to say something? Right. So it would be filtering, right? Whether it be firewall, whether it be routers, whatever filters, yeah, you would use that if you want to connect the two. Right. So you may just want to separate them out. You may not want A, B, and talk, which is, unlikely. But yes, that's right. So you do the segmentation mainly due to the security domain issue. Okay. And then you say, but sometimes I want A to be able to talk to B, and vice versa, but only sometimes. With what Dave mentioned, let's say with a filter. Okay. So let's just put a simple router between. Okay, maybe ACL, access control list, and to control access from going to left or right and vice versa. Okay, so in order to do that, there are a couple ways. One is to do this. You take the two ports that are on the different VLANs, and then you physically take the cable and stick a physical router in between, right? Two interfaces on the router, two ports on the switch. Very wasteful, but it'll still do the job. So it's a router now. Yeah, like I said, it's very wasteful, Terry. Yep, exactly. So then the next thing we could do then is take one port, right? Take one port and make it into a trunk port. So now it also it sees, right? It sees VLAN 2. So make this into a trunk port. It says VLAN 1, 1 and 2. Okay, and then stick a router. Okay, and have two virtual interfaces, .1 and .2, something like that. So it will understand. It'll have tagging. There'll be a frame that would have the tag that says, hey, I'm from VLAN 1 and hey, I'm from VLAN 2. And the router, although it's using one physical space, physical connection, will have two logical connection, interfaces. Okay, so this is called a router on the stick. They actually do call that router on the stick configuration. Okay, so yeah, but still though, you still need a router. Okay, and then you say, wow, it's a pretty expensive thing just to have these switches talk to each other. The different segments on the switch talk to each other. Isn't there a better way? And is there a better way? Terry, I was thinking about the other way around. Switches with built-in routers, right? So switches with built-in routers are what? What are they called? Or switches with built-in routing capabilities. What is that called? Soho routers. No, like I said, Terry, switches, not routers. Switches. So what is a switch that has the routing capability? You're thinking too hard. Yeah, Lisa. Smart switch. Okay, so we may be talking about the same thing, Lisa. So I'm thinking about a switch contains this routing capability, okay, and it's called the layer 3 switch. Is that what you're thinking about, Lisa? Yeah. So the layer 3 switch does not have a router in it, but it is able to route between the segments, the VLANs within the switch. Okay, it's able to do that, but it's not a router in that it doesn't speak router speak. It's not. It doesn't do router. It doesn't have a routing protocol. It doesn't have any of those things. Okay, so there you go. And so that's a layer 3 switch. And at this point, you know what? Because it's almost at the bottom of the hour, and we only have maybe about 30 minutes before lunch, so I think I just go on, okay, so that we can just go ahead and break in 30 minutes for 1 hour for lunch. I hope that's okay. And I can pretty much finish this thing. So now I want to go back to the original whiteboard that I was talking about. I think it's this one. Okay. Okay, so now I'm back to the original one. So now we've actually now moved up thanks to the layer 3 switch, okay, into the network layer. Now we're moving into the network layer. Okay, so now into the network layer, we have layer 3 switch. Okay, oh, sorry about that. Okay, so we have layer 3 switch. Oh, I'm missing an eye, sorry. So we have layer 3 switch, and we have a router here as well. Okay. So what does a router do? Like, what is the function of the network layer? What is the function of the network layer? What is it supposed to do? Guys, I made juice this morning. It's like fruit now. It's really thick. What does the network layer do? It has a very, very important function. In fact, people make their livelihood just out of network layer. Right? Cisco engineers and stuff, they make their life out of the network layer. What do they do? What's their value? Don't know? Okay. The reason why I wait 3 seconds is because I went to airborne school, and that's when the black hats told me that I should wait 3 seconds before I open the reserve chute if the main chute doesn't open. So that's why I'm waiting. I'm waiting for the reserve chute to open. All right, so I'm going to count 3 seconds. All right, and if there's no answer to network layer, I'll answer for you. 1001, 1002, 1003. Network layer routes. Right, it's the entire purpose of the network layer is to route. Okay, route things. And we were talking about PDUs. So this would be layer 3 PDU, protocol data unit on the OSI side. But when people talk about packets, that's what they mean right here. In TCP/IP, the network layer stuff is called packets. So routers handle packets, whereas the bridges handle frames. Okay, so it routes. Now, can you think of then? So we'll talk about routing a little bit, but can you think of any other devices that may reside at the network layer? Can you think of something? Okay, no, huh? All right. So then, what I'm going to do then is I'm going to open up another whiteboard and do a little lecture on routing protocols. Okay, because network layer, all we do is route in network layer. Okay, so with TCP/IP as an example, it needs to know the IP addresses. It doesn't care about the MAC addresses, but it needs to know the IP addresses because these are the logical addresses that spans the whole entire internet, right? Not just the local segment, which what the MAC addresses